Hello, friends. Welcome to the ATC Double Cut. In this episode, I want to talk about OM246 total organic material testing, and specifically about the reports. I was looking through some of my old videos and old blog posts, and I found one with the title OM246 Reports Explained. And I realized that this is something that I continue explaining even today, and I thought it would be a good chance to remind everyone some of the key things that you can look at and use to make decisions about turfgrass management, surface management, based on OM246 testing and OM246 reports. And this is something that will be useful for people who do have OM246 data, or for people who are doing it for the first time. And also it might entice you, if you don't have this type of test result from your facility, it may encourage you or entice you to try doing this because the results are really valuable. This is a post that I made almost exactly 3 years ago. It was 2021 October. So it's 3 years ago from the time that I am recording this. And it is a video that I shot out in an orchard and then combined with a production in the office where I showed some of the reports. And I had recently at that time updated the software that I was using to generate the reports. It's been updated some more since then, but these key things that I thought were so important then are still what I think are important now. And I want to review these and explain real quick what each one of these can tell you. These are ways of looking at the data from total organic material tests that are done. I do these at Brookside Labs, and you can get these tests done through me. You can get it done through any Brookside consultant. You can get it done through the United States Golf Association Green Section, and all of these tests will be run at Brookside Labs and done in a very standard way. I know some people like to say, well, we're just going to do it ourselves, so we're going to send it to a local laboratory. And I can't tell you how many times I've had to tell people who ask me to take a look at the numbers. I've had to tell them, well, I can't exactly interpret these results properly because the method is either unknown or the method is done differently than the standard method, which is what I've been doing for years at Brookside Labs and what the USGA has done at Brookside Labs also. It's done in a standard way. And this is not about a methodology podcast. This particular episode is not about that, but I just encourage you, if you want to do OM246 testing, just do it properly and don't try to roll your own, essentially. So what we're trying to do is measure the total organic material in the soil. And the first thing that I think is most important, the thing that I find the most useful on these reports, and it's explained in this video, and that is, let's see, I'll bring that up. I'll put a direct link to this post in the show notes, so that you can look at this video, and it's got links with specific timestamps so that you can go to these sections and see. But the thing that I think is most important is looking at the total organic material time series. It's looking at how the organic material in the soil changes over time. And it changes over time based on three things. It changes over time based on how much organic material is produced based on grass growth. It changes over time based on how the organic material decomposes through natural processes. And it changes over time based on the work that you've done, such as sand top dressing or punching holes and adding sand or doing sand injection through DryJect or something like that. So there's 3 ways that it changes, and you're able to check that exactly. You're able to check the effect of your top dressing. You're able to check the effect of not top dressing and trying to let nature take its course. You're able to check the effect of adding fertilizer and growing more organic material, or cutting fertilizer and letting the organic material stay the same or reduce. You're able to check all of those effects. Looking at that time series is really important because it is like a timeline of what your results have been from the work that you've done. And it can give you strong suggestions or insight into whether what you're doing is working, if what you are doing is having the desired effect, and if what you are doing should change. Perhaps you should be able to add more. Perhaps you should or you need to add more sand in order to keep the organic material from increasing to an undesirable level. So it's this organic material time series that I think is most important. And that's why for people who are on the fence about this and who are thinking, maybe I'll get going with this next year, maybe I'll do this sometime, you can't have a time series until you have a starting point. So I encourage you to get started with this. Get started with this testing that is so valuable in allowing you to refine and adjust your organic matter management. I used to give seminars 10, 15 years ago where I said that managing the organic material at the top of a sand-based root zone is about the most important thing that you can do, because if you don't manage that effectively, then the desired characteristics of the root zone will be destroyed. They won't exist anymore, and you will have suddenly an unsuitable growing environment for grass, and your grass won't be able to grow. The fear is that if you have too much organic material, that you won't have enough aeration porosity. If you don't have enough airspace in the soil, then the grass roots aren't going to grow very well. The grass won't be very healthy, and water won't move through that organic layer very well. And that's quite a concern. And I used to recommend standard amounts of coring and standard amounts of top dressing in order to manage. I called it managing that organic layer or the organic material that accumulates at the top of a root zone. But I wasn't really measuring carefully what was happening and what the results of that management were. I was not checking it. Since 2017, I've been recommending to do this type of OM246 testing. And if you are doing this and you've been doing it since 2017 or 2018 or 2019, then you have a nice timeline. And if you haven't been doing it yet, you can get started now. And if you get started now, then 6 months from now or a year from now, when you test again, you'll have a timeline. You will see how it compares from the start, because you can't compare the results of your, or you can't evaluate the effect of your maintenance practices unless you have a starting point for organic material and a recent test result. So that's why I think this organic material time series is so important, and I would encourage everyone to look at that carefully. But it's always interesting to know how your greens, how the organic material in your greens and your grass compares to others. And that's where the next thing that I show on the report and that I think is very interesting to look at, that's where this comes in, which is the OM by depth by species. And what this shows is a type of chart that shows your latest test results, and then it compares your test results to what's normal for that particular species. And on the reports that I give, it shows for that particular species at a particular depth, it shows what percentage of samples are above your test results and what percentage of samples for that species are below your test results. So from that, you can say, for example, what I'm showing on the screen now is Zoysia core greens. If you have Zoysia greens and you have 12.7% organic material in the top 2 centimeters, which is right at the surface layer of the green, that would put you in the 58th percentile. 58% of greens of that species are expected to be below 12.7%. 42% of greens are expected to be above that level. And whether you've got bentgrass greens or Poa annua greens or fine fescue greens or ultradwarf Bermuda grass greens, from my data set of samples from all over the world, from golf course putting greens, and a bit of statistical wizardry and computing power, I am able to make this analysis that shows what percentage of greens are above or below your test results. And I think that is interesting to look at because you can see how yours compare. I also show a scatter plot. And in the scatter plot, let's see, there we go. So I'm showing on the screen a scatter plot, which is showing the total organic material by depth, and it shows each one of your samples, and then it shows it's in a bright red color, and it shows at that depth what your organic material is. And in the background are a lot of gray points that show all the other samples I've measured from all other species. Sometimes I get results and I think the samples were taken incorrectly. And the chart that I'm showing on the screen shows samples that I'm confident were taken correctly because the values are normal. But I've sometimes seen samples at the 2 to 4 centimeter depth or 4 to 6 centimeter depth that are so strange that I think people haven't measured the depth properly. Or sometimes I've occasionally seen samples where these are supposed to be a 0 to 2 centimeter depth, and the test results come back as if somebody has just taken a 0 to 10 centimeter depth sample or 0 to 4 inches, and then they want to test that for total organic material. And then they'll call that OM2, but the samples actually go down to 10 centimeters or 4 inches. So of course you get a result that will be like 2% organic material, which is off scale low. And those tend not to be my clients, but it's sometimes when people are asking me to review the results, that's something that people will send me the numbers and say, what do you think about this? And I'm like, you know what? I think you've either taken the sample properly or the person who sent you those results took the sample improperly, or you've sent it to a lab and they've done a completely different test. So it's interesting to look at this type of scatter plot just to see how you compare not just to other greens of that specific species that you're growing, but compared to all species. And you can just see, are you normal or not in terms of the organic material in the root zone. I also do some of these tests for approaches, for tees, for fairways. And for those type of areas, I have a scatter plot on those reports that compares you to the same type of grouping. So if you, the same type of area grouping. So if you're testing fairways on the report, I would show you this is how it compares to other fairways rather than comparing to greens. And then the final thing that I look at for the OM246 data is the entire surface layer. So it's not breaking it down to only the 0 to 2 centimeter depth and only the 0 to 2, 2 to 4, and 4 to 6 levels, but I show this across the entire 0 to 6 centimeter root zone layer. And that's where if you are doing cultivation, or if you're doing, hollow tine or solid tine aerification, or if you're doing DryJect, and if you're putting sand and you're trying to put it into sand channels, whether those are channels that you create or whether it's a machine that's doing sand injection, you're going to be having a big impact on the top 6 centimeters, which is also the top 2.4 inches of the root zone. So if you're looking at 0 to 2 only, that's just really looking at what's happening right at the surface, and that's the combination of top dressing or dusting practices combined with the sand that goes into holes through cultivation. And by looking at this entire layer, you're able to see how things change over time, and is the overall total amount of organic material at the surface of the root zone, is that going up or going down? So I like to look at all of those things. I like to look at all of those 4 specific types of charts: the amount of organic material and how it changes over time by depth. That's the first thing and most important thing that I like to look at. Then, for a snapshot in time and a comparison to how the greens currently are compared to other species, compared to the same species, then I like to look at the next chart, which shows that comparison to species. Then I like to look at a scatter plot to see how everything compares to every sample that I've ever taken, basically. And just make sure from looking at that chart, you can say, okay, there's a lot of greens that have more organic material. Or you may look at it and say, if you're Joe Galati and you've just gotten 21% on your OM2, you would look at that and say, wow, I'm about as high as you can get with OM2. And that's why if you've talked with Joe about how he's managing the organic material, you'll see that he's been adding quite a bit more sand this year and doing some coring to try to remove some organic material and to create space really for sand to go into the root zone and to help reduce that organic material. Now the greens were still performing okay, but he said he had some infiltration issues that he was concerned about, and reducing the total organic material at the surface of the green is expected to increase the infiltration rate. So look, this type of testing is so useful because it's disruptive to do the cultivation work and to add the sand. So by doing OM246 testing on a regular schedule, I recommend annually doing it year after year after year at about the same time. If you're really, really into this, do it every 6 months to get even more data. But as you do this and you start developing that time series, you can then see, wow, I reduced my organic material by 4%. I went from 21% down to 17% in the top 2 centimeters. And that shows that the sand that was added had exactly that effect. And you can justify the disruptive work that is done. And if you find that it didn't have the desired effect, if it did not reduce the organic material, then next year or next time we do cultivation, let's try to do a more effective practice. Let's try to do something that has a greater effect. So the scatter plot can be really useful just to put things in the big picture compared to every other sample that's in my data set. And then I like to look at the entire layer over time because, for example, if you just say, let's just top dress and top dress and top dress, you end up burying the organic material. You'll take your level of organic material that was relatively high near the surface, and you'll end up moving that lower in the root zone, but it still it takes a while to move that below your top 6 centimeters. So you can see then, is that organic material just getting lowered, and your total organic material through the top 6 centimeters, even though you're adding quite a bit of sand, it may not change very much. So you can look at that, you can see how it changes, and these numbers help to they don't just help, they provide invaluable guidance on how you can adjust the maintenance practices to get even better conditions, and how you can not only get better conditions, but you can do that for more days in the year and do that even more efficiently. That is a video that I think is quite good. And that blog post kind of summarizes the key points of the video and puts links to some direct timestamps in there if there's any specific part of the report that you want to check out. I'll just read the end of this blog post. What did I say? I said, after trying many different ways to look at OM246 results, the ones that I now find most useful are the 4 that I show on the report. I describe these in detail in the video, so if you'd like to hear more about what these charts are showing and my comments about what I find especially relevant, please have a watch and listen. So that is the post with the title OM246 Reports Explained. I'll put a direct link to that, and I encourage you to check that out. I now have more things that I put on the OM246 reports. So if you opt into this, I recommend everybody do opt into this. We will check the particle size analysis of each layer after you've burned off the organic material. So now when you're putting sand top dressing, you can see if the sand top dressing that you're applying, how that's having an effect on the particle sizes at different depths in the root zone. And that can be really useful, again, in evaluating if the sand that you're adding, whether it's through top dressing over the surface or whether it's sand injection or whether it is sand that you're trying to work down to certain depths in the root zone. I've seen some people are using one type of sand for top dressing over the surface, a different kind of sand that they put into holes. These types of maintenance practices can be checked if you do the OM246 testing combined with the post-burn particle size analysis. So I recommend that for everybody, and that is an entire new section that's on the current OM246 report. I know a lot of people are collecting these samples or have collected these samples or will be collecting these samples, and I encourage you to take a good look at the results and make decisions based on those results that allows you to achieve the results that you're looking for. I trust that you will look into this, because you can't just get the result and say, okay, I'm at 7% organic material. That's too high for me. I want to reduce it. You have to look at it a little bit more carefully. And I think where it really is useful, where it's most useful, is evaluating the effect of the work that you've done. So I think I've said that enough times, and it must be very clear by now. So thanks so much for watching and for listening. I will be back again soon with another turfgrass topic to discuss. For now, I'll sign off for ATC from Trong, Thailand. I'm Michael Woods. Bye-bye.